There. Oh, it's morning for you, right? Okay,
Yep.
you're being recorded. Today is Thursday, October 10th, and we have John Armstrong here from New Zealand, and he's gonna share the goodness of the Visual WX Query Designer. And I'm gonna go to mute right now. And thanks, John, for doing this.
Yeah, you're welcome. Thanks for the opportunity to share a bit of my knowledge. Look, just setting the scene a bit, this came about from the chat group and his Skype group from John Fligg. John wanted to set up a query in order to make his veterinary application run more optimally. And so in the end, it was easiest to explain his problem by setting up a little wee miniature database, which I've got in front of you here. I in fact used Microsoft Access just because it was faster for me to dump data into. And this is the structure of what we've got here, just to describe quickly what it is. Once we've got this sorted, we'll go in and do a few queries. So first up, what we have is a primary record for an animal, which is linked to the type of animal, a dog, a cat, whatever, the breed of animal, and also the use, whether it's a farm animal, a pet, or whatever. And I've made joins between the animal and two of the three children tables. Firstly, the type. One animal can only have one, it's either a dog or a cat. And secondly, same with the breed, and there ought to be a join here. I've left that out just so we can demonstrate a feature when we're making a query. So relatively simple sort of a database, and it's got just a few records on it, and we'll jump straight in and make a quick query. So that's the analysis into the query editor. To make a query, right click and new query. Actually, I'll just pause here for a second and just describe how I use queries and why perhaps you might like to use them as well. Basically, I'm a bit of a query junkie. I like to set up in advance all of my file access, what I'm going to be extracting from the databases I write as queries. My workflow, if you like, is I'll design a query, I will test it, put in parameters to see if the result set that I'm getting back is correct. I will then from there, I may add some summary information, adding up some totals or putting some formulas in there. Once I'm happy that I'm extracting the data I need, I'll then use that as a basis for a view or a report or accessing data. And I just find it really easy to compartmentalize, whatever it is, make into compartments my program so that it stores all of the relevant procedures quite separately. I can test them, prove they're working, and I can use it throughout my app. I can also share my queries with a colleague here she does my reporting, and she can build a report. I can get the logic right and pass it over and say, here's a report, go ahead and make it. So I reckon it's a really powerful way of working by working with queries. I know that the this group who are absolute ninjas when it comes to writing SQL. They can just write screeds of code for SQL and make it work. I'm a visual sort of person who like to do that, but you can follow the process where you create a query, use it to create some SQL code for you and copy and paste it into your application. I'll show you how to do that as well. Now, firstly, when selecting queries, we've got different types of queries and how we use them. Select query will grab a data set for you, which you can leap through or summarize. Insert queries allows you to, as it says, insert a new record in there. Updating is cool if you want to change a value on a data set. Union queries are not used that often, but they're actually very useful to join two discrete data sets together so you can browse through one large data set. And we're going to do a select data set right now, or sorry, delete as well is useful where if you want to get rid of a whole batch of data out of a table programmatically, you can call a delete query with the various parameters on it. Okay, let's do a really quick query in relation to our animals table here. This here is the query designer, and what we get is a nice little view of what's in the analysis. It shows us down the left-hand side the tables we want, and we'll do a really simple query just with a single table at this point here. We'll grab the ID of the animal the animal's name and its date of birth and appointment date, for example. Now, there, folks, we've just created a view of the data, and I've just clicked on OK. It describes it diagrammatically, where it shows us details of which file it's drawing the query from, and then the query, it's currently got no name. Now, if we run a test of the query, it'll prompt us and want us to give the query a name. So we'll just call this one animal list. It's not all that exciting, and bang, we'll get to see at least some of the data that comes out of the database. Oops, a daisy. That was not what I was expecting. Actually, Arnold, would you mind pausing the recording here? I believe that I may need to check out something with regard to the Windows update that's just happened. In fact, I might need to go offline for a second. Sorry about that. I should...
So, John, you're back on.
Yes, and I've just discovered a minor problem with the test data I've got here. I believe that I was getting smart and putting an appointment date in the original table, something which I was just playing around with, but I don't have that in my main data file. So what we're going to do is have a little diversion and learn how to synchronize the analysis with an external data file. So in this case here, we go to the structure of the files, we go to update the analysis from the external database, and it'll walk us through asking us to check the different connections in the database. I want to connect my my link to the Access database here. So it's asking what I want to synchronize. I want to check the common tables only. I've actually got all the tables out of the database, and it tells me all of the errors that are, sorry, differences between what's in the real database and what's in my analysis. Now, a couple of points here. It's warning me that there are changes in all of these three areas. One in the animal table, and that'll be that appointment there. It's also warning me about these links that I've got in my analysis. Now, indeed, I added those links to the analysis. They're not actually in the Access table, so it's warning me it wants to delete them. I'm going to turn that off because I do want to retain those links. But in the animal table here, it wants to make a change. Let's just have a look at the details and see what it wants to change. And it wants to change the animal name, and again, I was playing around, I made that a key. I might just make it so it's not a key on the animal name, and the appointment date it wants to delete. I'm going to ask for both those changes to be applied so that the animal table here matches, in the analysis, matches what's in the real world in the Access database. So click on OK to that, and you can have it perform this operation every now and then. I like to run that sort of thing manually, but you can have it prompt you and it'll check for differences and fix errors. Okay, now you'll notice our table has got a few less columns in it. So there you go, there's a little diversion, something new we learned, how to synchronize the real world with your analysis. Okay, back to the creating queries. Let's have a look at our animal list here. It detects that a change has been made in the analysis, so we'll go away and apply that change, and with luck, it's going to refresh the project for us. It's going to delete the appointment date out of my query. Back in a second.
Oh, this is a great example of adjustment. I love it. Nicely planned.
It's actually really handy, the features. If I'll perhaps divert while we're in this area, because it's well worth knowing how to. You'll often, or I develop with databases other than Hyperfile. I like particularly Postgres and SQL Server, and inevitably they get out of sync. You end up having new views you've created, you want to bring them in. So what you do with that is you go into the structure of files here, and you're able to update the analysis from the external database. And as you saw, sometimes you may or may not want it to make all of the exact changes. In this case here, we'll just run through that little process again. It lists all of the databases to synchronize. Now, I was just playing around with connecting through to Excel spreadsheets just for the heck of it, so it's left a couple of extra connections in there, but I want to do the connection to my Access database, and it says check the common tables or all tables. That simply means that do you want to look at tables that are not in your analysis, and it brings up a nice list of all of the things that are wrong. And like I said, these two changes here, if I click on the details, it just tells me what it will change, and so it's going to delete that link. Now, as that link is something that we actually want for this demo, we're quite happy that it's different, but that's a really cool feature, the ability to suck in changes. It also works the other way, where you can push changes from your analysis and update your external databases. So let's say I wanted to, I could add a column into here, and in fact that's what I did with that appointment column. I just didn't do the final step, and then I can go structure of the files, and then where are we? Generate SQL script. We'll create a script to update the changes to your animal file into your SQL database or Postgres database or the like. So if I click on this generate SQL script, I say which of the tables I'd like to put into a new SQL database, for example, or a Postgres database, change from Access. I'll pick the whole darn lot, go to that. It asks me what sort of database I'd like to create it in. We'll go for SQL Server here, and you've got various options to say whether you want to drop the tables or how you want it to perform, and you end up with a script, which is SQL, which you can just run in the query analyzer, for example, in your SQL database or in your Oracle database or whatever, and this will create a table called animal, which has got the various columns in it. It'll create the indexes. There it is, creating the breed table, and it'll add the foreign keys and the like. Literally click on the copy, go into your other database, press paste, and bang, it's created the database for you externally, and then you can carry on with your synchronization process. A small caveat, there's often a little bit of tweaking you may want to do in some features in the other databases, but it gives you the bones of a totally working database very quickly from your analysis. So your workflow could be design your external database here in the analysis, the WINDEV analysis, export one table at a time or all the tables into an SQL statement, and open up your SQL Server and go from there. So yeah, there's a little tip that has accidentally come into the demonstration. Okay, let's get back into making a few queries with this table. Hopefully it'll work this time. So this is a view of that animal list query we made, where it's got the animals table, and it's going to make a view of that table. It's got three columns in it: the GUID, the name, and the date of birth. Right click, query description. We'll just have a look at it again to see what it was doing. There it is there. That's our analysis. Okay, let's run that and just see if that gives us what we're expecting. Run test query. Please work this time. Okay, that's better. Right, we now have a preview of the data that's visible, and we can see we've got these animals: Grace and Lucy, a pair of dogs; Trigger, a horse; another horse; Daisy, the cow; Lassie, Flash, and Harley. Actually, I think Daisy's the bloodhound off the Dukes of Hazzard. Anyway, you can do various extracts of the information in your query there just to see how many animals you've got and averages and all the rest of it. That's a little bit by the by. Okay, so we could now go into our code and call a query called animal list, and it would make a nice little browse like we just displayed. The next thing we want to do is we might want to get some sort of selection criteria on there. So or sorting on there. Right now, it'll just be, we'll do sorting first. Right now, it'll just be by the animal GUID. It'd be probably more sensible to sort it alphabetically. So if we click in this column here, or use this button here, I like use this column here, this is the sort column, click here, and up comes a sort in ascending, descending, or don't sort. So we'll click in ascending order, and so now it's going to do all of the animals in alphabetical. We could also perhaps do it within animal name by date of birth. Probably not the most sensible thing to do, because the date of birth is like to be more granular than the sorry, not much sorting will happen. So we could perhaps even change round the display order. We'll do date of birth first and then the animal name. So in order to modify our sort, we could just turn those off or go into the sort function here, edit the sorts, and it shows us how a list will put the date of birth at the top, and in fact we'll change that to the youngest animal first, and bang, now it's doing number 1 will be date of birth, number 2 will be animal name. Right click, select that, run a test, and we now have the youngest animal is Flash, the oldest one is Mr. Ed, born on my birthday. Okay, back to our query design here. So we've now done quick sorting. We may also want to do some selection criteria. The second column here is the selection criteria. Click here and you can apply some conditions to your query. This is where it starts to get really powerful, where you can start including or excluding things. So we'll click on the conditions here, and up comes a dialog which says, what would you like to make your condition on? Because we're highlighting an animal name, we'll do something with the animal name. So what we'll do here is say, well, we want to do all animal names starting with K or is greater than K in the alphabet. So we'll do greater than equal to the value K. So I'm going to pick animal names greater than K, sorting it in animal date of birth order, right click, run a test of the query, and bang, we've got Lassie, Lucy, Trigger and Mr. Ed in there, again from youngest to oldest. Now the next little trick is you may want to see what the code is in behind that. If you right click, you can go SQL code and you can view what the SQL query is. This is the way that no doubt those experts like Andy and Pete would actually just code this off the top of their head and make a perfect query every time in the middle of their code. I'm a bit of a visual person. I like to actually create it via a query, test it and see what happens, and then I'll copy it and paste this into my code if I want. But here we go, we can take that and copy and paste it into the code. You can also even edit this code here. The danger is though, as soon as you edit this code, we want to get rid of, say, the date of birth column, which is a little bit odd, but if we wanted to do that, it'll give us a warning. It'll tell us that if we're going to start mucking around with the code, WD basically says, over to you then, mate. You're the one who's all of this, and I'm going to take away some of the features I give you to control it, because we could put any sort of code in there. So you suddenly go outside the bounds of their programming, and you need to have something, you need to be in control from now on. I actually prefer not to change anything in here, and will always do my changes through the screen here. Okay, what we've done is pretty basic so far. Where queries are really handy is when you're wanting to link other tables into it. So if we go into our query description here, we'd like to list our animals and have the breed, and in fact we'd like to have the, or also by type of animal, and we'd like to have the animals with all of the horses together, the dogs and the cats together, etc. So we open up the breed table here, and we'd like to have the breed type in our list somewhere. So we'll select that and put it in the list. In fact, it's easy to view stuff from left to right, so we're going to put that, drag and drop, and put that at the, no, we're not going to drag and drop and use that and get it to the top of the list. And so now the animal type is going to be at the top of the list. We might change our sort order as well. We'll get rid of that sort there, and we'll sort it instead. So we'll do it by breed, and then we'll be able to see the youngest and the oldest by breed. So here we go, it's been sorted by the, sorry, the type, my apologies, the type, and then it's going to be an animal date of birth order. So now here's where things start getting interesting. We get a few pretty pictures here, and what we get to see is a visual representation of what the query is going to do for us. What it says is, here's our type file, here is our animal file. It's going to select all animals with a name greater than K. If we, here is the sort, and if we hover over it, it tells us that it's sorting the type name in ascending order, and it's joining the tables between the keys that we defined in our analysis, which in this case here is the type GUI is stored here on the animal table. So let's run that and just see quickly what's coming out. I don't know if you can tell, but it's really nice and quick the way you can just make quick changes incrementally just add things to it and see what the result is going to be. I know that you'd spend a lot of time in front of pages of code doing this strictly by coding rather than doing it visually like this. And it's kind of instant feedback, instant gratification. A, getting a result, and B, the results look like what you're wanting. So here we go, we can see the result. It's sorted by dogs and horses. Let's actually lose that condition, so we'll delete the condition so it does all of the animals and run that test again. And there we go, we've got the dogs. The pigs, interestingly, it's not actually done exactly what I was wanting to do with the type name sorted. Okay, I think I might have, let's go in here and just double check the sort condition. It's doing it by date of birth first. My apologies, I wanted to sort it differently, so we're going to edit the sort parameters and we're going to put the type at the top. Now we'll get the result we're expecting. And that's, I guess, the sort of thing which by doing it visually, you can see a result and see, that don't look right, there's something wrong. Now we've got cow, dogs and horses and pigs all nicely sorted. We've got the animals within there and they're sorted from the youngest to the oldest. And that's pretty straightforward. The thing which I think prompted me to write a quick video tutorial for John was the complexities of dealing with where you have null values in your joins. In this case here, it's quite nice. We have one type for every animal. But if we modify the query and introduce to it the breed of animal, I know that one of the breeds is not there. So I'm going to put the breed name in here. Bear with me while I get this sorted. So beside each type, it's going to show the breed, and we should have 8 animals coming out of it. So let's do a big OK to that. And here we have it. Everything's joined between the appropriate keys. In this case here, the breed is going to the breed ID, and it's all nicely linked. And when we run the query, we expect to get our 8 animals coming out. So we run a test of the query, and we've actually only got 7. Mr. Ed is missing. Mr. Ed's missing because we don't have a breed for Mr. Ed. So when the query is run, it's looking where the breed ID on the animal is equal to the breed ID in the lookup, and that ain't there. So Mr. Ed is missing in action. Okay, to fix that, we want to deal with this little join here. This is where the fun starts. So we want to say that we want an animal where the breed is optional and indeed the type is optional, because maybe somebody forgot to enter a type. So right click on the join, edit the joins, and it comes up with a dialog which asks us about how the joins should run. You literally just tick boxes, answer questions, and good old WINDEV will do all the heavy lifting for us and give us a result like we're expecting. So in this case here, the question is, it says include a row per breed without a type. So include a row per breed / animal that doesn't. We actually want to do that. We want to get animals that don't have a type of animal, if that was the case. In this case, all of our animals do have types, but that's a good thing to make sure we don't have errors in the future. Secondly, it says include an animal without a breed. That's exactly what we want to do, because poor old Mr. Ed ain't got a breed, and so he's not showing up at present. So there we go. We've now changed our joins, and we've made what's described as an outer join, and that will then change the display, and here we are. Takes a little bit of getting used to, but we now get a new visual on it, which helps us understand what we're seeing here. Now, there's some subtle things in here which are pretty cool when you understand what it's trying to tell you. Firstly, it's changed this little join statement here from being left and right with 2 empty diamonds or triangles to a dark diamond, which is saying that we want everything from the animal table and we'll optionally take things from the breed table. And ditto, the same left outer join is being described here, where it's showing we want everything from this side of the query tree, and it's optional to pick up the type here. In fact, I'll just change this join. We'll go right click, edit again, and we'll say we'll allow animals without a type. Sorry, animals must have a type. And now you'll see it showing an equal join. So what we know, just looking at this quick visual, is that the query is only going to return situations where there must be a type, or else it won't return that row. So right click, edit join, and we're going to make that type optional. It puts on that there, and let's have a look and see if Mr. Ed comes up now. And here we go, Mr. Ed's there. He's got a null in the breed name column, but we're happy with that, and we now have our horses all listed in there, all the horses and the other animals. Okay, the next thing I wanted to show you quickly is how we deal with a query with a file which is not related in the analysis. Sounds a bit odd to perhaps not link things in the analysis. It's actually really useful to do that, but there are times, especially I find creating views in my databases, that I will just have orphaned views that might sum up and total things which aren't strictly linked to the table they link to, and I'll join them manually. So here we go, this use table, the use shows us whether it's a farm animal or whatever. That's sitting there as an orphan all by itself, and so we want to put the use description into our query here. So grab the query, right click, query description, and we're going to grab the use table, whether it's a dog, a cat, or whatever. So grab the use description, chuck that in there, and in fact we'll put that right at the top so we can see whether it's a animal or whatever, and right, we'll just run it as is. Now there it's searching for the joins, and it comes up with this warning. It's detected that we've just created a Cartesian join. What that's basically saying is there is no, it can't see a one-for-one relationship between the indexes, because we didn't define that in our analysis. So it will end up doing a cross join, which will put everything linked with everything in there. So every animal is going to show up many times as it links with a cat. A dog's going to match to a farm animal, and it will match to the pets. And in fact, best way is just to look and let's see what's Cartesian bring joins. So it now tells us here we have a Cartesian join which looks different from this. Let's run that and just see what our query now looks like. So if we run a test of the query, oops a daisy, right, this is an interesting phenomena. What we've got here is a limitation of the underlying database. Access is not really a fully fledged database. It's a wonderful tool for doing ad hoc things, but it's not really anything you should run your business on. And it's basically saying here that Access is spitting the dummy and saying, I don't like doing Cartesian joins. It would have worked fine with SQL or Postgres and the like. So anyway, let's get rid of that Cartesian join, and that way it'll be all sweetness and light again. So edit the join, and we've got a problem, Houston. There are no tables listed in the join, and that's because in our analysis numerical we didn't describe what the link is. So the fix is to manually set up the join. If I go to add, it simply asks me which tables I'd like to join together. It drops down a list of the columns or of the different tables, shows you what are the likely ways you want to join it. Now it's listed here all of the GUIDs. It may be though that you actually were joining on the name of the animal, and you'll see the animal name is not listed in here, and so you do have the option, as well as the items that WINDEV suggested for you, you can also go to this picker here and grab the animal name if you want to link to your other table with animal name, which, I don't know, you might have a foreign table that's got a list of the popular baby names from 2013 and want to link by name to see how popular the name of the animal is compared to names or something. So while WINDEV will attempt to do nice things with your selections, you could do something off the wall and pick something other than the standard links. Excuse me, got a frog in my throat. Right, back to here. We are linking, just to refresh my memory actually, we're selecting the use of the animal with the use table. So we pick from the animal table the use GUID, we pick from the use table the use GUID, and OK to that, and are presented with our familiar question about, do we want to include a row for every use that doesn't have a type? And yes, we sure do. The reason being is it's technically possible that an animal may be classified without a use, and indeed you'll see in this case that is exactly the case. Click on OK, and here we have a nice little join, just talking through these symbologies again. It shows us how the dark triangles on the right, so everything comes from here. If it can find a match, it'll bring it from this side. Everything comes from the left-hand side of the tree here. If it can find a match, it comes from here. Everything comes from this side here, and if it can find a match, it's showing there. And let's run that and see what comes out. So running the query, and we now have the use description. Daisy's a cow. We've got our pets, our racing animals, and our hog there, the farm animal there. Okay, so that's a really quick introduction to queries. I thought what I might do is now put this into context as to how I use queries by giving you a quick overview of an application which I created this time last year. We have a large health provider here in New Zealand who there are tens of thousands of health workers who go out and look after accident victims in their homes, doing domestic care and assistance paid for by the government on a compensation scheme we have. This program, what it does is it consolidates all of the timesheeted information from about 10,000 odd workers amongst different service providers, collects that data, creates a CSV file, submits it to the funding agency, and receives funding back from the funding agency, which is passed on to the provider to pay their staff, and it does various checks along the way. It's a WebDev application, and this is it here. It's got a bit of a oops daisy, have timed out on the thing. It's got a bit of a Windows 8 theme to it, and you basically can, our delivery partners put claims in there, we process those claim files and submit them, prepare for a gaudy colour. There you go. I made the colours of the screens the same colour as the buttons, and we're going to be looking at this screen here, which lists all of the files that are awaiting processing, awaiting remittance from the funder. So this long claim list here shows the individual CSV files that have been generated by the program and submitted to the government funder, and we get to see which ones are still waiting to be paid. There's millions of dollars a month that goes through this thing, and good old WINDEV does, or WebDev does a fantastic job of getting everything working. The reason I picked this was this screen here is created off a single query. The query is quite interesting because it has various sums where it's adding up. We're going to use this to show how I do query. It's adding up the value of the claims that have been submitted, how many lines are on that claim, and literally I created this by creating a view on the SQL database. It then is the basis of my screen here, or table, we like to call it in the WinDev world. So let's moving right along. We'll have a look and see how we did that. So here's the WebDev screen and behind it all, and we're looking at the this table here. If I right click and go to the code of this table here, it's all being run this query here, which is called claim submitted to ACC missing a response. So here is that query over here. As you can see, I'm a real query junkie. I've got that I'm using throughout my application. You soon learn to be very particular in your naming, so you know what things are happening, or sorry, what the query is doing. Always for verbosity over brevity, I find. One day you'll wonder what something does, and it's a hell of a lot easier if you simply give it a long name. In this case here, these are claims that have been submitted to ACC that are missing a response or missing a remittance. So we'll go on that little puppy, and here, Control W to maximize the screen perhaps. Here is the query that's going on here, and we're picking a bunch of files or tables out of our system. In this case here, we've got 1, 2, 3, 4, 5 tables. We have got various contracts, or it's got the contract table, the user table, different claims, claim lines are submitted, and you can see just from this visual query designer that we have views which are, we have a left outer join here or an outer join where we're taking everything from the claim line, but we want the remittance, we want it where we haven't had a remittance against a claim. That's basically the crux of it. We're saying, give me every claim that one of our delivery partners has submitted where there is no remittance line from the funder, from the health provider, the health funder. So we've created a join to do that. And in fact, this is a special join, it's a standard outer join, so we can tell from the symbology that we're getting everything from the claim line, and we allow nulls in the remittance line. And we use that fact to, in fact, give us the result set. What we do in order to get all lines that are all claim lines that are not yet paid is we say, give me all claim lines linked to the remittance line where the value is null. And so if there is a link, it'll actually not print the claim line. The selection criteria, as we'll see in 1 second, says only show me all items where the intersection is null, which gives us everything that's unpaid. Very cunning, works simply, and I made this query, checked it, made sure it all looked right, checked the numbers, it was good, and there we have our join over there. This here is just an equal join where all of these must match. This is our only outer join. So this also does some grouping. Grouping we'll also touch on in a second, and what the grouping is doing is it's grouping to summarize. So as we saw when we're looking at the, where are we here? We're not looking at the individual claim lines, we're looking at 2 claim lines here with that much money. We're looking at 184 claim lines with $33,000. So we're grouping it into the individual CSV files, and we're going to get some totals out of it. So back to this little query here. We'll go into the query description, scary stuff, and we'll see all about the joins we've created here with the criteria, the grouping. We've got the summary information happening here, and we've got a bit of sorting going on, and that's our query. So into the query description, and here is the query we've selected, and there's a sort. It's sorted into batch number order, as we saw down here. This is the batch number, which is what we've submitted our funding under. It's just sequential. It's also got a couple of count items in there where it's counting the number of lines on each claim, and it's also counting the remittances at ACC. It's a nice little summary here where it's adding up the total of all those lines with a sum. So we'll come to that perhaps in a second. We'll look at this this criteria here. This is the interesting one that I was describing here with this join. I've got a criteria on this count here where it's saying give me all claim lines where the count of remittances is null. So if I click here, I can go in and modify that condition so we can see what it's doing there. And it's basically, in this case here, I'm setting it, or sorry, doing it a different way from what I described, was perhaps slightly more confusing, but literally I could have done this by saying is null, might have done it, or I could say where the value is equal to 0, and if the count returns nothing, then it will, if there are no remittance lines or 0 remittance lines, it won't display the that particular summary. We also have in here some totals, like here is a total, which is the total amount that was claimed. To add a total to a query, you take the value that you want to total, in this case here, we might grab a total out of here. The units claimed in decimal, and if we wanted to add up the total number of units that were claimed on here and show that in the browse, we would pick the sum here, and now it's going to sum up that and stick the number of units as well as the dollars in the query. I can go down here and give that a nice name. Sorry, here where we change the name of it, we can give it an alias and call it just sum of units or something like that, and it'll give it a slightly different name in the outcome. So that's how you would add a summary to your table and get some numbers. Really easy to do, and a heck of a lot easier perhaps than looping through and adding things up. Yeah, and away you go. So anyway, that's kind of a mega query which I use the same workflow I was using when doing our animal testing before. That's not a right way of putting it, animal query tests. And what it showed is I could check to make sure the totals were looking right, that the summaries were working, and so that slightly complicated looking query, but really it's not that difficult, is used over and over again. I never need to go back and change it, and I can use that query in a report or whatever. So if we wanted to add a summary to this table here, let's say we wanted to count the number of animals per breed. Let's go ahead and do that right now. So we'll go into query description, and if we want to count the number of animals, we'll perhaps grab the animal GUID. In fact, there it is there. We'll just use that there. We'll go to count, and we'll count the selected item, and we'll count the number. You'll see here it says count the number of different records. It'll get rid of the duplicates for you if you want. We'll just count individual. It would have made no difference. In fact, this to the bottom of the list, and it's added in a count function, which perhaps it's easiest just to see the result, and you'll see what we're talking about here. And it's counting one animal because there is only one animal on each row. But if we can make it actually show us how many dogs or horses there are by just modifying this query. Grab the query here, and we'll take out the actual animal's name from our list. That button there loses it, and we'll take out the breed name as well. Okay, because we've changed the query, it wants to detect the joins again, and it's detect them like we had them before, which is all good. When we now run the test, because we've taken out a few of the columns, I had expected that to, no, I need to group it, take out the use description, sorry, the date of birth. What it's doing, it's seeing that there is a unique record, because I've left the date of birth in there. Easiest to just show you what happens if I take out the date of birth, and it will summarize it just having use and type in there, and then we'll see some real counts. Again, a deliberate error, yes, yeah, right, which is showing how by doing things visually, you can spot errors you make as you go along, and that was an unintentional, deliberate training error for you. So here we go, run a test. Wham bam, thank you ma'am, we've got 3 dogs in there, 2 horses, 1 pig, and 1 cow. And so there we've got some summary information coming up. we could do some other clever stuff like let's put the date of birth back in there and we'll find the oldest animal of each breed. So chuck in the DOB, grab this max min thing here, and we'll do the minimum date. So now it's going to show us the oldest animal in the breed, and we can give that a nice name if we like. Run the test, and we can now see the birth date of the oldest animal, which is quite cool. The other thing is you can always go back and see what the SQL code to do that, copy that into your source, and you've now got yourself a query that's in code and not linked to your defined query, and you can use that to if you're a code junkie and prefer to use code rather than visual queries like I do. One other thing which probably we're getting to the end of the list of all the different things I can do with a query, but sometimes you want to pass a parameter to your query in code to make it do something. So let's say you want it to be able to, within this query, we'll just view it quickly here, we want it to show just one at a time all of the farm animals and the counts for the farm animals. So we wanted to select by use description only in our code. So we just want to get farm animals for farm animals, other things, and then pets for another query. So we need to put a selection criteria on the use description that we can call in code secretly. So right click, query description, and under the type of animal name, we'll click out here, which is the new condition, and in the conditions area, you'll see that you can pick all these nice things here where you starts with you can create a list, a nice comma separated list. You'd like a list of these 4 types of animals, etc., etc. We'll do an equal to here, and rather than specifying a value, we could specify where it's equal to a few possible values and do, actually we're in this area here, we'll do dogs. It would then do only dogs. We want to make this a parameter that we can pass in the program, into the program. So what we're going to do is say parameter. I like to grab this here so that my parameters are nicely named and have parameter 1, which is the animal type name, and we can now programmatically ask the query to do that. If I click on OK, it's now got a selection criteria in there, and it shows us in here that it's where that's equal to something. If I run that query now, because the query has now got a selection criteria, it pauses and says, what test value would you like to put in there to test it? So we'll put in horse, and bang, it shows us the details of the horses, and the oldest horse, Mr. Ed, is in there, and you can run that. That selection criteria, by the way, is only for this test. It doesn't overwrite what you might call in the code, but when you call this query in the code, you just need to say run the query where parameter 1 underscore type name equals dog, horse, cow, whatever, and this is for testing only, but in your live code it would run it like that. So that's how you pass parameters around, and you can get complex with your parameters and do, in fact we'll do that. Let's say you wanted to get, your complicated parameters are useful because we can do ands and ors. Let's say we wanted horses or dogs in here. So what we're doing is dealing with 2 criteria on this same category, and so if we go, we can make a new condition against this line here, and we can have where it's equal to the parameter 2 underscore. And bang, we're done. We've got 2 parameters on there, and this again is a deliberate error. It ain't going to work when I ask for a horse and a dog. So that we'll do parameter 1 is dog, parameter 2 is horse, and of course it's going to find nothing when we run it. A horse is a horse, of course, as Mr. Ed would say. And bring up, it's looking for any animals that are both dogs and horses, and there ain't no such beast, so nothing there. Okay, what we want to do here was an or rather than an and. So right click, query description, and we're going to go into the selection conditions button down here, and we're going to change the condition so that rather than being an and, which is the default, it becomes an or. So here are our 2 parameters, and it lists down here that it's parameter 1 and parameter 2, and if it had more parameters, it'll just keep on listing out here. What's really nice is you can start doing some flash Harry stuff here. You can put an or in here, and it'll now do that or that. And so it's now changed the selection criteria from an and to an or, so it's parameter 1 or parameter 2. And now when we look at our diagram, it's slightly different. We've got a little bit of an or going on there. Just make it bigger for us. And when we run the test of the query, it's got horses and dogs, and because we're doing ors, there we go. We can see both of those. You may also want to do an and, another query in there. Just let's get more complicated. Go into the query description, and we'll add something new where the count, it's got to have more than 1 animal in it. So here we're going to do a selection on a count field, which is pretty darn cool. So we're going to go and say where the count is greater than the value 1. So it's not going to return any categories where the horse is greater than 1. However, it's not quite going to give back what we're expecting in its current form. I'll run it to show you what comes out, but it's going to be slightly different from what we're expecting, or what I would be wanting to do. Right, it's got both categories in there. It has worked, but it's accidental that it's worked. Let's go back and have a look at our query description again. What we see, we've gone and put an and an or together. We really should have a quick look at our selection conditions, and we see that it's doing 1, 2, or 3. Actually, it has worked better than I thought. I had expected it to do to need a brackets like that. And in fact, it's possible that you may have wanted criteria 1 and only criteria 2 where there was more than 1. So you can do some flash Harry stuff like, sorry, that should be and. So in this case here, it will give us all of parameter 1, all of parameter 2, and where parameter 3 is not. Anyway, starting to make some complicated joins there, but you can do some cool stuff with the parameter editor there to join together all your conditions. Hey, there's my dog, Lucy, golden retriever, wanting to join the discussion. Anyway, I think I've probably covered as much as I should in this session here.
Hey,
perhaps over to the
John.
gang. What?
John, Terry has a question. He says, can you define limits like top 10 or top 100 using this editor?
I believe so. To be honest, I haven't done it, but that'll be in the situation where you have a count, and I would expect it's in the conditions for the count. So you might want to do the top 3 most popular animals here. So let's give it a go and see what happens. Hey.
Oh, I see where you can say the count. Oh, well, let's see. How would that happen?
Yeah, but you're after the top rather than the count, so it's slightly different.
In other words, you're saying you're a match, you're a match, you're a match based on a certain sort order, and then say that after 100 of them or 3 of them, I don't want.
Yeah.
You don't belong.
The answer is I don't know at the moment. I expect you probably can, but
I think you could.
Yeah. Oh, hang on a second. Sorry, there it is. There.
Terry,
Terry,
what does the code look like by hand?
No, here you go. The top 100 records, or the top 5 records, or whatever.
There we go.
So there you go. The first 3 records, 2 records.
So you sort it, then you say the top 3. Oh. It's based on the sort first.
Yeah.
So when he says top, so when he says top 10 or top 100, it's the top 10 or 100 of what, first, and then you you do what you just did.
What we want here is just the first n. Now, if we put it into the sort order, we're sorting here. So the first 3. So I'm just thinking about how you do percentages, but you can do the first or last X number of records from this limit here. Make that as a percentage of the total. I suspect you may have to jump through a hoop or two, but you could probably do it by counting the number of records and some sort of formula from there. In fact, formulas is
John,
one other thing.
I think.
Yep.
John, I think you hit it on the nose. If you use that and you sort it by whatever criteria you want, and just say I want the top 3, I think that does it right there.
Yes, that'll do an absolute.
You just have to have the right sort order.
Percentage.
Correct.
Right, Terry?
Yes, that's what I was asking.
Yeah, I think that should work for you. You just have to have the right sort order, then you use the first 3 or the first n.
Yeah, the only disadvantage to using the editor is you can't use query hints. But
you can't use query hints. Are you sure?
I don't think so. We've tried it. At least I think I tried it when we were at one of the conferences.
So you copy it over and then you add it yourself later?
I just don't use it.
Oh, okay.
But it is a good tool for what he's doing, and I think that makes a lot of sense.
Okay.
Okay. Hey, look, one other little thing, a couple of other little things that might be useful is you don't have to stick with just the items that are in your analysis here. You can query. Here's a query I created for the original video I made, so you could query fields out of another query, which may help us get those percentages we were just talking about there. The other thing is you can create calculated items where, let's think of something here. If we go new calculated item, we could get, say, the age of an animal. So it prints in years how old the thing is. So you can use SQL query statements, or you can use W language functions. You can grab the age, double click there, go into the animal table, grab the date of birth, and etc. etc. Now this ain't going to work, unfortunately, with the Access database I've got, because it's not a native driver. There are some limitations with doing this, but if you have a proper backend or a hyperfile backend, you can create your own calculated. So we could have in our query all of the ages and years of the animals. In fact, I might in that mega query I was looking at in here. Let's just have a quick in there. No, I don't. But anyway, play around with that, and you've got some back to where you've got some options there to add other things other than just standard table elements into your queries.
Cool, man. Any other questions? John, Alan, Tim, Wolfgang? Hey. We got some typing going on here. Yeah, you could see it if you clicked on the all my questions have been answered. John Flegg says all his questions have been answered, and he thanks you.
Hey, you're welcome.
And Terry says, good session. Tim thanks you, John. And Michael says, slightly off topic. Can you comment on GUID versus IDs?
Right. Look, I called them GUIDs in this case here simply because I was making a demo for John and he'd use GUIDs and his one's there. I like to use in a database that's not being replicated, I always use a numeric primary key on every table that is an auto-incrementing key. Because I don't use hyperfile, I use the auto-incrementing that's in the back-end database, the SQL database or the Postgres database, and that gives me an integer to link. And a database that's all in one place and it's all linked all the time. What I mean by that is when you start getting into the realms of disconnected data, where you've got an app that's on a cell phone that's disconnected, synchronizes, at that point in there, you need a unique identifier for the customer you've just added on your cell phone that's not in the main database. Things start getting awfully messy with auto-incrementing numbers. So in that situation, use a GUID. A GUID is effectively just a number. It's represented with the letters, the hexadecimal letters or whatever, F, sorry, so that it's in base 16, but it's actually a great big long number where there are basically more numbers than there are atoms in the universe, so the chance of a randomly generated number on the cell phone clashing with an ID in your main database that's using GUIDs is infinitesimal. So in essence, GUIDs are a way of giving you a unique number on all of your devices so that when you synchronize your data, they're all one. GUIDs are, even though they look horribly inefficient, being such a long alpha string, under the bonnet, they're good for indexes and yeah, they're useful. Some downsides of GUIDs are because they're random, the data is not in any order when it's added to your database. That means that if you've got a clustered primary index, i.e. in my case, for example, the transactions are being created with an integer. If you add 4 or 5 transactions today at different times of day, they're roughly in the same place in the database. So indexes, when the database is being read in blocks, it's quite likely to efficiently numbers around it and react pretty quickly. If you're adding those same transactions using a GUID, the index could have those GUIDs in any old sequence. So when you've got hundreds of thousands or millions of records in your databases, the transactions for the last week, in theory the database could be a little bit slower in fetching stuff, but so my recommendation would be use the as your primary keys unless you need to have a situation where you've got to have offline creation of indexes. Anyway, that's just my 2 pennies worth. Others know lots more than me. Anything else we can help you with?
Michael says, other than a penalty, the size penalty, why not use GUIDs all the time?
There's another problem I have with GUIDs, and that is where you start wanting to manipulate data outside of the database. It's a pain in the neck when you're copying. I want to add a new delivery partner into here, and so I create possibly an Access or a spreadsheet details and paste it into my table, and it's easy enough to know that the ID of the new provider is 78. But when you're manually manipulating stuff and you see that the ID is some great big long 32 character sequence of numbers, it kind of becomes messy dealing with it outside of the real database. If everything's in your database and it's being running as an application, it's really easy to do that sort of thing. Perhaps an example is when we run this query, we can see that the ID. We don't have an ID on here, but before we could see the IDs were really easy. We knew that trigger was number 8. If you wanted to add something to trigger, you could paste them into a table just saying that 8 is the number you use, or you get some great big long number which is just difficult to remember. So it's not really a very good reason not to use them, but it's kind of simpler to deal, I think, with numbers rather than GUIDs in that perspective. Use them when you need to, but otherwise I kind of stick with.
Makes it harder for people to guess what your next number is, or guess the another number in your database, though. You know, kind of like in.
Absolutely, and that's definitely a very good reason to use them as well. But that's perhaps only an issue if you're giving somebody a backdoor to access your database in that perspective. Supposedly with a web interface, your users shouldn't be going anywhere near that sort of level of the data.
Okay. Wow, you did over an hour. That's really good. A lot of good information, though.
Too much.
So looks like this is a good time, and John and you both like this time of the day. So maybe next we can have another one. Maybe John might want to do one sometime from the UK. Okay.
Fantastic.
Thank you, everybody, for coming. And my lunch hour is over.
Thanks for.
That was a pleasure. Anytime. So let's see. I am going to stop the recording shortly. Wolfgang says, thank you. Great information. So you got a lot of thanks, John. And I will put the recording up shortly. Take care, everybody. Have a great... Oh, we'll see you tomorrow morning with Wolfgang talking about his more basics.
If I'm still up, I'll definitely listen to Wolfgang. I might be in bed by then, but yeah,
Bye now.
Thank you, everybody. Goodbye.